curious about this YouTube thing. I'm just checking it out.
Yeah. All right.
I'm good.
Thank you for joining us tonight at UW Space Place. This is our guest speaker night, and our guest speaker tonight, I'm pleased to introduce, is Dr. Amanda Bauer, who's the Deputy Director and Head of Science and Education at the famous and historic Yerkes Observatory. And so tonight she's here to tell us about the 125 years of history and a bright future for Yerkes. So please help me welcome Dr. Bauer.
Thank you very much for having me. Nice to see some new old friends in the crowd who have quite a history with Yerkes themselves. And hello everyone online, if anyone is online. So I came to Wisconsin about 15 months ago. That's when I moved here to start working at Yerkes. And so that has been quite an in-depth learning curve. I wasn't necessarily a historian before. I'm an astronomer by training, and I'll tell you a little bit about my history, but it has been an absolutely fascinating journey trying to get to know Yerkes and all of its technical equipment and getting everything up and running again and really bringing it to life in a way that it hasn't been in quite a few decades. So I want to give you some of the history part here, tell you some stories of the people who've been there, some of the things that they've done. Then I'll tell you about myself and what the status, like what brought me here to Yerkes and really what we're doing now, how we're bringing research and arts and education all back to life in this legacy of a place. So my official role is Deputy Director for the Yerkes Observatory. Yerkes is now a nonprofit run by something called the Yerkes Future Foundation, and I'm also the head of science and education. So I got my hands in a little bit of everything in this organization. Oh, is that me?
Do you have a phone in your pocket?
No, I got one right here. I can move that. Oh yeah, crackly. So Yerkes Observatory was founded in 1897 by the University of Chicago. They owned it all the way up through 2018. And it is the home of some very influential astronomers. George Ellery Hale, here in the middle, was the founding astronomer, the inspiration. Founded Yerkes when he was in his early 20s. And his vision for this place was to have the largest telescope in the entire world. And he did that. And it was the largest telescope for about 10 years. And then he went on to Mount Wilson and founded the next biggest telescope in the world, and then the next biggest again, and the next biggest again. So 4 times in a row, this man was able to convince people to pay money to build the biggest telescope in the world. It's a very impressive thing that he was able to accomplish. And actually, just last weekend, I met his grandson. His name is Sam Hale, and he came to visit Yerkes Observatory for the first time since we've taken over ownership. So that was pretty fun. Edwin Hubble, of Space Telescope fame, he did his dissertation work at Yerkes in the 1914 to about 1917 when he was there. And then for some reason, Scientific American had the cross-section of the Great Refractor at Yerkes on its cover of Christmas Day, 1909. Not entirely sure why that coincided with the holiday, but it did. So this was also the home base for the Astrophysical Journal from Hale's time of founding all the way through till about the 70s or 80s when the University of Chicago took it over. This is a place where most research is published. Most of the papers that I've published with my research are in the Astrophysical Journal. So I can kind of go through our libraries and see all of the print copies of that. And in general, it was just a place that had a deep history of innovation, of discovery. They brought together optical engineers and engineers who were at the pioneering phases of developing astrophotography as a science, as an entire thing. It really, all astronomy was visual. You only looked through a telescope with your eye. But photography for astronomical objects was really developed here at Yerkes in the beginning of the 1900s. So that legacy kind of continued throughout the history of Yerkes. These are some photos of the Great Refracting Telescope. It still is the largest refracting telescope in the world. So that means that the light goes through a lens, kind of like a giant magnifying glass. So at the end of the telescope, up at that end, you've got a lens, and the light comes to a focus 63 feet down this metal tube down here. So that's where you put your instrument to capture a photo, or you put your eye to look through the telescope. That is just a gigantic telescope. One of the other innovations they had at this facility was to develop reflecting telescopes. So it's hard to imagine scaling up from this mechanical feat that they did in the late 1800s. You'd have to have a tube that would be longer and a building that would be bigger than the 90-foot diameter that this dome is, that rotates 360 degrees so that the doors open in the place where the telescope is pointing. Because they knew that mechanically they were probably not able to increase the size of the refracting telescope, Hale put a man named George Ritchie to work to really refine reflecting telescopes, which means you use a mirror. So you have the same piece of glass with the curvature in the opposite direction. You put some kind of reflecting coating like aluminum or something like that on it, and then the light comes in and it bounces off the mirror and it bounces back and forth between mirrors. So those are the most common ones that we use today. And in that way you can make your telescopes a lot more compact. You don't have to build these gargantuan buildings around reflecting telescopes. So some of the first modern designed reflecting telescopes were also built at Yerkes. They had this great optical engineer. And so that next biggest telescope was a 60-inch mirror that was made at Yerkes and was then shipped, well, probably trucked, all the way across the country out to Mount Wilson in California. So the innovation continued through its life. One of the famous visitors to Yerkes early on was Albert Einstein. You can see him right here. It is said that this was his first visit to the US ever, and on this trip he wanted to see two things. He wanted to see Niagara Falls, and he wanted to see Yerkes Observatory. So he came through. This is a photo of him, 1921, with the staff at the time, and you can tell that there are a lot of women, kind of a surprising number of women in this photo from the 1920s. Here he is with the second director of Yerkes, Edwin Frost, and Edwin Frost was a really interesting character for quite a few reasons. One of them, in the historical sense, is that he really was a leader unlike other leaders that were in astronomy at the time, in the sense that he called himself a suffragist. He was really supportive of women being able to do science, which was not common at this time. In fact, some of the most famous astronomers that are women were at Harvard at this time, but even them, Henrietta Leavitt Swann, Cecilia Payne, could not use the telescopes. They were not allowed to use the telescopes. All they could do was analyze the glass plate images that came from the telescopes. But at Yerkes, Frost enabled a program where the women, he recruited them. He looked for women who were excelling in their field and brought them to Yerkes to do kind of regular 3 to 5 year stints, and they could use the telescope. They were running their own programs, which was totally unheard of. Now, unfortunately, a lot of the women got so used to having that freedom and respect that they did not always go on to have long careers, because when they went to other institutions, they were not greeted with that kind of respect and a capability to do their work. So that's kind of the sad side, but the fact that Frost was able to create that atmosphere is really an honor to him. If you're more interested in that, the University of Chicago right now has an exhibit open through December called Capturing the Stars, the Untold Stories of Women at Yerkes through 1930. And it's a really great thing. They've got all these kind of historic objects and letters that Frost wrote back and forth with the women, negotiating their salaries and where they would stay, and staying in the Van Beesbrook's house and like different places around the area in Williams Bay where the telescope is located. Another interesting thing about Frost, you can see a lot of photos around this time. This is from 1910. Their whole families, they started a ski club, you know, they would do all kinds of things. But he went blind during his tenure as the director of an observatory. And so it started in about 1915, and he was director for almost 15 years as he was losing his sight and went fully blind. And yet he was still able to function as the director because he was so good at training folks. His hands still know what to do. He could still describe to people how to take observations and how to do that research. And there's still a sign on a door outside of my office, and it says, "Keep this door completely open or completely closed at all times," because it sort of opens into a hallway. So if it's halfway open or halfway closed, he could walk right into it. So it was very strong paste that they used, and it's still sticking on that door. We don't really follow those instructions anymore, though. But so there was a lot of work done on galaxies at Yerkes. This is an example of a spiral galaxy. It's one of my favorite objects. It's one of the objects that I study in my own research. It's a collection of stars and gas and dust, and there's a supermassive black hole in the centers of almost all of them. It has something like 400 billion stars. That's what causes this collective glow around this object. And one of the like between kind of 1940, 50, and 60, there was a lot of research focusing on galaxies, and a lot of things came out of Yerkes Observatory. One was the understanding that our own Milky Way galaxy had spiral arms. So Hubble went off, and in the 1920s, at one of the observatories in California, he said, our galaxy is not the only one. Every single one of those little fuzzy things in the sky are individual galaxies. So all of a sudden in the 1920s, we went from thinking we were the only big structure in the universe to, oh my gosh, there are thousands and thousands of them. And then we really got down to the study of what do they each look like and can we find patterns. But what we couldn't do was jump on a spacecraft and get outside of our own galaxy and look back into it to see what the shape of our galaxy looked like. And it was at Yerkes with Nancy Grace Roman on the team who discovered through a series of different kinds of observations that our galaxy was a spiral galaxy with spiral arms. And it was kind of amazing that they came to that conclusion considering the data that they had at the time and how accurate they were at locating the exact spiral arms when I look back at the kind of data that we have today. It was a really amazing conclusion. So Nancy Grace Roman was there in the 50s. She did her graduate research. She might not be someone whose name that you recognize immediately in contributing to research. She did a lot of great work there and ultimately was hoping to stay at Yerkes, but by this time, the cultural attitude had shifted quite a bit, and it was not, she had a hard time trying to get tenure. It was not welcoming to a lot of women at that time, and so she decided, nope, I'm gonna leave Yerkes, I'm gonna go off and do something else. Hello, more old friends. And so she started to look for a job, she did a couple things, and then she became the first chief of astronomy for NASA. So, you know, not incapable of doing really good work. And it's kind of joked that the second chief of astronomy called himself the first male chief of astronomy at NASA. Her work at NASA was really critical in understanding the concept of how to build the Hubble Space Telescope. She brought engineers and astronomers together in the same room to really hash out the details of how we could make this thing possible, and then went and convinced NASA and government to give money to the development of the Hubble Space Telescope. So, so much influence that she had on that, in fact, that there are two incredible things about her. One, she has an official Lego minifigure. And we keep that in our library. We show that off. This is her with the Hubble Space Telescope. And number two, the next big space telescope, think like James Webb Space Telescope that you heard a lot about in the last year, the next big one is named the Nancy Grace Roman Space Telescope after her contributions to the field of astronomy. So this is pretty cool. And the fact that she spent so much time at Yerkes is definitely something we're going to be talking up in the next few years. It's scheduled to launch in 2026. All bets to see if that sticks. Space telescopes aren't very good at keeping their dates. So I want to mention a couple more folks who came through Yerkes before I start moving into the more recent future. This is Margaret Burbidge. She was also there in the 50s. She did a research postdoc at Yerkes. You can see here with this really cool carrying case of little glass slides that have astronomical images on them. She attended a workshop at Yerkes, and from that workshop, she was inspired to study the composition of stars. We didn't really know what stars were made of at this time, and so she dove right into this research, and she figured out, like one of the skills that she had was kind of bringing together multidisciplinary areas of astronomy research and kind of connecting them. So the astrochemistry, the spectroscopy, the imaging, the study of stars, the study of galaxies. She was the first person who really put together and discovered that every element on the periodic table, from carbon to uranium, was made in the centers of stars. That was her. And then a few years later, another famous astronomer who I'm sure you've heard of, Carl Sagan, who also did his PhD at Yerkes Observatory, kind of reframed that discovery in the famous line, "We are made of star stuff." So they didn't really overlap there as far as I know. Maybe my timing is off, but it was just kind of interesting that they contributed so fundamentally to astronomy and the popularization of astronomy coming out of that place. This is an image. There are lots of group images outside of the building. You can see the beautiful facade of Yerkes. This was an American Astronomical Society meeting that was taking place at Yerkes. In fact, the very first one happened 125 years ago at Yerkes, and they're celebrating that in January at the next big AAS meeting. These days, something like 3,000 people attend those. It's one of the biggest meetings of professional astronomers in the world. And here, another photo that was taken at that meeting was Chandrasekhar here at the left, who probably spent 60 years of his career at Yerkes and the University of Chicago and won a Nobel Prize in the 80s. And then the other one, whose name you might recognize, is Gerard Kuiper, about the Kuiper belt that's in the outer parts of the solar system. He was director at Yerkes for a while. And then Bill Morgan, who was between the middle on the right side there, he led the research that discovered the spiral arms of the galaxy. Nancy Grace Roman was one of his students. And then George Van Biesbroek, who was a neighbor of some folks in the audience. Now, the reason I show this photo is because you can clearly see right there on the brick on the facade of the building, Yerkes Observatory, University of Chicago. Chicago owned the observatory until 2018. They decided in April of 2018 that they were going to sell it. No idea what was going to happen to it, but that was the statement. And October 1st, they locked the doors. And so there was quite a bit of just unsureness, really. Professional astronomers, nobody really knew what was going to happen to Yerkes at that time. So what did happen was a group of folks who live around Lake Geneva in Wisconsin, that's where the observatory is, about an hour, 20 minutes from here, got together and decided they wanted to save this historic property, this beautiful building, the 50 acres of Olmsted-designed landscape around it, and they didn't want it to go to a hotel or private properties or a mall or any of the number of things that could have happened to this building. A spa, I think, was one thing on the table. So they put together this thing called the Yerkes Future Foundation. And this is a nonprofit. The goal, I might have, yeah. So they were created and took over ownership in 2020. They had a goal of raising $30 million. We're about 2.5 years into that campaign, and we've raised about $19 million so far. And the photos I'm showing you here are the restored parts of the building. When they took over the building in 2020, like buckets of water were pouring in the roof. There was so much leakage. They had to completely replace the roof. They installed solar panels. I say they because I wasn't part of the organization at this time, so I can't take credit for it. They still had the old, like 1900s, early 1900s wiring. Anybody could have died from that, so they replaced all of the wiring. They refinished the marble walls. They pulled out the decades, the century of smoke that had been absorbed in that porous marble. And then the university coats and coats of paint that were all over the place. They kind of stripped all that back and then repainted. The solar panel, or the skylight that you see up there, had been tarred over so you couldn't see it. So we opened that up. There was an entire other skylight that we opened up for the first time since probably the 1960s. This beautiful library. This room is what we call the programs room. It used to be 2 offices, and we tore a wall out of them and created this space where we could actually have about 60 people in a program. So the point is that it was about 1.5 years of full construction to get this place up to the point where the bones could hold it up. There was real worry that it was just going to kind of fall in on itself. And now it just looks stunning. It's really beautiful. And so what we're committed to is kind of reimagining this future of Yerkes Observatory, where it's really inspiring creativity, exploration, art, and a connection with the cosmos that allows imagination and collaboration to come together. So scientific curiosity and just general curiosity about the world around you can come together in unique ways. So, I mean, we kind of think of ourselves as a place for big ideas. So we have had a speaker series this summer. We had Nobel laureate Dr. John Mather come and give a presentation. He won the Nobel Prize in Physics. We had Tracy K. Smith, who was a 2-time US Nobel laureate, come and give a presentation. She wrote a book called Life on Mars. It's a book of poems. And her father was the first Black engineer who worked in NASA. He worked on the Hubble Space Telescope. So this book won a Pulitzer Prize, and it was kind of her musings on her relation to astronomy as a field and as a, existential thing that we all kind of deal with. So it was just an honor to have those types of people come through, in addition to really building up our actual education and research program again. So what I want to do is step back a little bit and talk to you about myself and kind of what I've done in my career and really what brought me here to Yerkes, because had you looked at that place or had I looked at it 3 years ago, I'm not entirely sure I would have come. And I'll be honest, I never thought I would be moving back to the Midwest. But this place brought me here. So I want to tell you a little bit about my career. Like I said, I am a trained research astronomer. I did my PhD in Austin, Texas. I got to go out to McDonald Observatory, use the telescopes quite a bit. Met a couple folks in the audience from those days. And then I went on and worked at lots of different observatories and used telescopes in Chile and used telescopes in Hawaii. I did some research in Germany at the Max Planck Institute. I went to England to do a postdoc, researching galaxies using some Hubble data, trying to figure out how galaxies form new stars and what causes them to stop forming new stars. And then I got the opportunity to go to Australia. So I had never been there before, but I managed to get a job called a Super Science Fellowship. And I was like, I can be a super scientist. So my nephew gave me a little red cape, and off I went to Australia. And I wore that cape quite a few times in professional settings, and for me, that was really fun. I didn't bring it today, should have thought. So here, most of these photos are from Australia. This is a 4-meter telescope that is about 7 hours north of Sydney. It's the Anglo-Australian telescope. And then that top part, on top of the white cage, there's like a black tube. Well, if that telescope comes all the way down, this is me sitting in that black tube. So I'm working on an instrument that's in there. It's called prime focus. So I worked a lot with optical fibers and integral field unit spectrographs. Just did a lot of hands-on technology and hands-on observing. My favorite things to do in this period were really observing using the telescopes. And also, I really started to develop my science communication. I like talking about science. Science writing to other professionals is very efficient. Some might say dry. And that was not necessarily my passion or what I found enjoyable. So what I started to do in my career was do the observing for my research teams, collect all the data and help analyze the data, and then I would help improve the quality of the papers. I wasn't the one who was dealing with all the statistical details and reproducibility and coding. I was the one who made it make sense. Those are the things I like to do. And I found that in Australia there were a lot of opportunities to get trained at science communication. Oddly enough, I was surprised by that. So one of the things I did was enter a contest where I was named one of the top 5 under 40 researchers and science communicators in Australia, which gave me an incredible set of opportunities. I had a 2-week internship at Radio National Australia, where I got to meet a scientist from every field and then also reporters from everywhere. So I got to do this podcast that was produced by the Radio National team called Cosmic Vertigo. I got the opportunity to interview Neil deGrasse Tyson on a couple stops around Australia in front of audiences of 5,000, very large audiences. And then I had kind of a regular live radio show, which aired at about 9 p.m. East Coast time. And I would go in and I would say, like, here's my top 3 interesting space things that happened this week or things that you need to keep in mind. And then they would take live calls. And you never know what people are going to call and ask about at 9 p.m. at night. So it kept me on my toes. And I will say one of the first times I did it, there was a producer who went through most of the calls to make sure they weren't like completely wacko questions. And there was a little girl who came on first, and she asked a very adorable question, and I answered. And then she said, "My brother's right here. Can I put my brother on the phone? He wants to ask you a question." "Sure, why not?" the radio host said. So this kid, who was probably like 9 or 10, got on, and he said, "Why are there rings around Uranus?" Live on the radio. And I really felt so proud of that kid. Like they worked together to make that happen. So again, like you have to be ready to answer any question soundly that anybody asks at night. So while I was in Australia, after my Super Science Fellowship ended, I was offered by the observatory a position that was it was half research and half outreach officer. So they'd never had one of those before. And so they offered me that role largely because of all these sort of opportunities and trainings that I'd had that raised the profile of the observatory around the country and world. And so that got me into thinking about astronomy and outreach and education from a strategic perspective. What can the organization do uniquely? What can it teach? What can it share with the world that nobody else can do? And that's hard when you've got like NASA around who does a lot. Do in addition to research astronomy. And so that brought me to my next venture, which was the Vera C. Rubin Observatory. So while I was pregnant in Australia, I applied for this job and I interviewed for it across the world with a tiny infant in the back of the room. Thankfully, she slept through most of it because it was at like 4 a.m. And I got this job. So I moved to Tucson, Arizona. It was the thing that brought me back to the States after about 10 years overseas. And the Vera C. Rubin Observatory is this huge telescope. It's an 8-meter telescope. It's one of the biggest currently being developed on-the-ground telescopes. This is from about 2019 when I got to go up to the summit. It's being built in Chile. It's still not finished. Construction got delayed because of COVID, so it's probably going to be finished next year, maybe early 2025. I arrived as the head of the education and public outreach team. And this was sort of fascinating because it was one of the only projects that was funded by our government. So it's a National Science Foundation and Department of Energy funded project, but they were giving money to develop an education and public outreach program during construction. This just hasn't happened before. So it was a very exciting opportunity. I got to go in, I had a pretty significant budget, I got to build a team, I had a vision, and got to really learn things about how to manage, how to have a team, how to manage software developers, which are very different than astronomers, which are different than educators, which are different than all the people that I had on this team. But we built this program, and I'm happy to say I wasn't there for the completion, but at rubinobservatory.org/education, for all of you online, you can go and see the program that's mostly online now. And you have access just through your phone or through your computer and the internet to go and really look at data that comes from these telescopes. And you can go from looking at, say, galaxies. They help you identify supernova and galaxies, and you work through it, and about an hour later, you have fully concluded that the universe is expanding. And they're just really cool activities. I'm not affiliated with them anymore. They're just cool. So I was there for a few years. And then because I was the leader of the education and public outreach team, I was also part of the overall leadership of Rubin Observatory and had the opportunity to move into the role of deputy director for operations of Rubin Observatory. So once the construction project is done, they hand it over to operations and they carry out the observations and do everything and get the science, get the data to the scientists to do science. So what this telescope is doing is kind of miraculous. It is a huge telescope. It's about 8 meters across. And the way it's designed means that it moves really fast. I just saw the first video of like the completed structure, and it looks like it's sped up. It's just crazy how fast it moves. So what it does is it has a huge view of the sky, and it takes an image in about 30 seconds, and then it shifts to the next part of the sky and takes an image, and goes to the next part. And it does that the whole night, such that every 3 to 4 nights, it covers the entire sky that it can see over and over. And its survey will last for 10 years. And so what happens is when you look at a spot in the sky several times, you kind of know what it looks like. You have a template for what that part of the sky looks like. So the next time your telescope comes and images it, if you subtract the two, whatever's left is everything that's changed. So maybe it got brighter, or it got fainter, or it moved, or it exploded, or it disappeared, or it appeared. And so what the project is doing, they're committed to calculating, so it's a data-intensive program, the computations they need to do. Within 1 minute of every observation, they calculate all of those things that have changed. And they send an alert out to the world for each of those things that they identify. So the position and the brightness and all that kind of stuff. They estimate that every single night, 10 million alerts will be going out to the public. So 10 million things are changing every night that before we just didn't have the computing capacity or the telescope to be able to identify. It's like a whole new set of eyes on the universe. For instance, my PhD thesis had maybe 300 galaxies, and I was like, that is a lot of galaxies for that time, like 20 years ago. And now, and I mean, those are great. This is going to produce something like millions and tens of millions of galaxies. Not only that, but it's not just a snapshot. Imagine like someone taking one picture of you in your entire life and being like, I know everything about this person. But now they've got snapshots of you all the time, so they can get a different perspective on what you do every day. So it's a whole new way to look at the universe. And arguably, this might be one of the most complicated systems, if you can imagine the data storage and processing and everything that is required of it. And so I was the deputy director of that project, and I decided a little over a year ago to say, maybe I'll just come to one of the most historic telescopes in the whole world. It's quite a jump in my career. Although, look, you can see the Milky Way from Wisconsin, so we got that going for us. It's not the most dark sky sight in the whole world, but you can still see. So why did I do that? I think fundamentally, let's see if I have the next slide here. No, not quite yet. Fundamentally, I was just really excited about the idea of a new organization that is interested in bringing science, astronomy, education, and like art and culture together at the core of its mission. It wasn't like, let's do a bunch of research and like tell a couple people about it. And it wasn't, we're an education institute and we have telescopes, which is kind of how things tend to go. It was really the opportunity to create this from the ground up, where we didn't have the University of Chicago institutional baggage, as it were, with us. We didn't have people saying, well, this is the way it's always been, so this is the way you have to do it. Instead, I had this opportunity to bring together the science communication, the education, the research, the telescopes, the management, the building teams, the budgeting, all that stuff together in this unique organization that we kind of like to think of as a 125-year-old startup. That's what we are. So my first task when I arrived 15 months ago was to see if the telescope still worked. There were no other astronomers on the team. At the time when I arrived, there were 5 people on the staff. There was the board, but none of them were astronomers. So there were 5 people on staff, also not astronomers. So the place was a construction site for a couple years before I arrived. This telescope was covered in plastic. The walls were covered in plastic. They had to do a bunch of masonry work. There was water sitting in between the layers of walls around the dome that they had to dry out. So I finally got to take the plastic off and see if the telescopes worked. I brought in the old directors, the old scientists, the old engineers who were still around the area just to kind of talk to them, teach me what you know. One of the disadvantages of starting an organization this way is you don't have that depth of institutional knowledge. So there were people who worked there for 30 years who could hear a sound, which you often do with historic equipment, and be like, oh, that's different. And then you're like, we got to figure out what that is. I didn't really know that. I didn't have a whole lot of experience with historic telescopes, so I needed to build up that knowledge. And the good news is that this great refractor still works. That's my daughter over there. She's master observer now. She actually, right on the side on the left, there's this finder scope, this thing right here. And so when you are pointing this telescope, you completely use your hands. It might weigh 18 tons, but you can move it with your hands because it's so perfectly balanced. As soon as we figured out how to grease and oil it all again. At first you couldn't do that. And so what she does is she looks through that finder scope and she helps take the object, usually the moon or a planet, something bright, and she helps us, she tells us how we have to move the telescope to get that object in the center. And she, as a 7-year-old, has kind of the most amazing communication in doing that, better than most adults I have tried to observe with. It's pretty stunning. So we have informally renamed the finder scope the Ida scope. That's her name, Ida. And she comes up and observes with me for a little while. In the summer it's hard because the sun sets so late, but she'll observe for a little while and then she'll go lay on the couch in my office and she'll go to sleep. Got a little sleeping bag in there for her. But late this summer, we had one observing night, and she was only able to really observe one object with us. And this summer kind of sucked because there were no bright planets up early, and there didn't happen to be a moon up. So we just had to look at a star. We looked at like Altair or something to get all focused. And she looks through after waiting patiently for us to get everything set up, and she's like, "Ugh, a boring star. I'm done." And she went off to my office, and that's where she spent the night. So my 7-year-old is a little spoiled when it comes to astronomy. But she sort of owns the place, so it's really nice to carry on that kind of family atmosphere that I think was really started with Frost and that has carried on throughout the legacy of the observatory. So this gets to the core of our mission that I described a little bit, this place where that doesn't really exist, that brings together science, environment, culture, arts, and curiosity in really unique and novel ways. This photo on the right is one of our other telescopes. This is a 24-inch reflecting telescope. The observatory has the great dome with the great refractor and then two smaller domes. One's got a 24-inch and the other one has a 41-inch reflecting telescope. So these are where science gets done. The big refractor is just kind of the visual marvel, but these two are the ones where we use CCD cameras and we really get the science out of these. So one example of this, you might think, I told you a couple examples of what does it mean to bring like culture and arts and science together. Gave you a couple examples. Another one is the world's tallest glass tree was built in the front yard of Yerkes in December. So there's a local glass artist from Northern Illinois, Jason Mack, and he builds this thing. There's a big metal structure underneath that and it spins. And so what we did is we got the entire community to donate green glass and clear glass to us. He brings a kiln on site and melts it, and then picks up the melted glass on the end of a stick, and as the structure spins, the glass just sort of falls off of it and produces a big long string, and as it spins, it gets pulled around. So you can see long, thin strands of this green glass. And this event happened every weekend, so this Friday night, Saturday, and Sunday in December. And we ended up building the world's tallest glass tree. And so you can imagine the connections with glass. We have these huge glass pieces in our telescopes. We have glass plates which capture the astronomical images from 1900 all the way till about 1970. We have a collection of 180,000 of those in our building. And so just that really interesting collection of glass, their real message is that glass is infinitely recyclable. So you can use it over and over for art, for real, useful reasons. And the good news is that we're going to be doing this again this December. So if you want to come and sit outside in the cold with us at Yerkes, we have a tent, we have little fires set up. We had some of the apprentice glassblowers doing demonstrations. We had hot chocolate, we had little local vendors. It was really a fun event, despite the fact that it was pretty cold last December. We had about 10,000 people come through to this free event. So everyone is invited. I'm looking forward to it. Is it still going to be the world's tallest glass tree? Probably by an inch, just to have that name. We'll do it. Okay, so the next thing that we have to do is have more astronomy expertise on the staff of the observatory than one, a staff of one. So this spring, or this summer, I was able to bring on Dr. Amy Steele. She's our Director of Astronomy and Research. She showed up in July. Yay! And she's really brought this core vision of access. And to her, that means access to Yerkes, access to the telescope at Yerkes, access for people who don't typically have access to the big funding from the government, or access to the computing facilities that you might need to analyze some of this data. So that's kind of the core of the message she's really bringing in building our research program. We also brought Mallory Conlin, who used to be here at UW-Madison. I think you said with IceCube is where she was. And so she's now working with us, and while it was more quantum that she was focused on before, her background is in astronomy. So for her, she's like, yay, astronomy again. But she's really starting up our education program and leading some outreach activities right now. And so between the three of us, we're the astronomy team. We're focusing on quite a broad range of audiences. Mallory's really focusing on K through 12 right now. And then from undergraduates to graduates, we're really interested in bringing opportunities for under-resourced institutions around Wisconsin, Illinois, and then broader. And then ultimately, we'd like to build up to be able to host postdocs, to bring research scientists, and to build up our astronomy faculty. Now, I'm going to share with you a little bit of Amy's insight into what that's going to look like. We want to dig deeper. One of the things that we can do with the types of telescopes that we have is not look at the most distant objects. We are not in space. We are not on a mountain. We are not in a dark sky site compared to some other places. But we can look at how things change over time. So when you're looking at transiting objects, it's when maybe you've got a planet going in front of a distant star. And so you can see a modulation in the light. There's quite a few other examples of transiting objects. We can make discoveries largely through variability and transits, so things that change in brightness over time. One of the things we're trying to look into is if we can contribute in follow-up observations or pre-covery through our glass plates of the Rubin Observatory. So when it comes online and starts telling us all these things that are changing, we have data to see how it changed 100 years ago, or what it looked like 125 years ago that nobody else really has. And then finally, joining forces. So collaborating with other groups, that might mean having time on telescopes that are a little bigger or in a darker sky site, collaborating with people who have large computing facilities. And we can try to be that connecting point between some of the smaller institutions who have students who maybe don't have an astronomy program but are interested in astronomy. I studied physics in a university that didn't have an astronomy program, so the opportunities I got to do astronomy mostly came from outside of my department, and it has served me well over time. So kind of trying to be that, connect sort of the haves and have-nots, or the maybe interested, we're not sure yet, but we don't have the opportunity to explore at our small college, is a thing we're thinking about. We also have the telescopes, and they can test new instrumentation and new technology before you try to spend some big dollars to build the big thing for the big telescopes. Lots of opportunities, some examples of that. So we've got our 2 telescopes, and they're the reflecting telescopes. They're also on the Skynet robotic network. And so you can operate them remotely or access them from anywhere in the world. So it's a really great place for hands-on training for students. As I said, Rubin is an example of a new telescope that people don't go to use. You have to be a fairly well-trained expert to actually collect the data. So you as an astronomer use the data, you don't use the telescope, which means that there's kind of a whole generation of students who don't have access to small telescopes to learn how they work. So it's hard to look at your data and maybe there's something in there that can be approved, but you don't know, you haven't had the chance to really take observations of your own to learn what you're looking at. So that hands-on experience with telescopes is something we want to provide for students. We have 180,000 glass plates, talked about that, time baseline. We're building up a program to digitize those so that they can be read into a computer. That is no small project. And then one of the other things I'll mention is workshop and conference space. It's just an absolutely stunning place to hold workshops. So this summer, we had our first astronomer in residence, Dr. Britt Lundgren, who's in the center of this photo. Here's myself and Amy. We had 4, we called them interstellar interns, of course. Then we had our 4 undergraduate interns who came. Some of them came from the University of North Carolina in Asheville with Dr. Lundgren, and some other ones we brought from the local region to Yerkes for the summer. And they got to do lots of fun things. They got to monitor the brightness of a supernova that went off right at the beginning of the summer. So they learned how to use the 24-inch telescope in order to do that. We worked with Dr. Kate Greer here from the University of Madison. She came and talked to the students, taught them about supermassive black holes, and then we tested the capability of the telescope to do some observing for her project. We had them scan some of these historic glass plates and make a couple discoveries of their own and really test how faint you can see with those objects in the part of the sky where Rubin Observatory is going to observe, to see if it is a feasible project for us to have like a pre-covery project ramped up from Yerkes. We're starting to welcome, right now, school's back in session, so we're starting to welcome classrooms again. We have a special relationship with the Williams Bay School, which is the village where the observatory is, but we're also welcoming lots of regional schools and families. Here's me talking to a school last year, and that's Mallory up in the front of the room at one of our public star parties where we invite up to 250, 300 people into the building to do hands-on activities, hear some different lectures, and look at telescopes on the lawn. We're also a great space for hosting kind of small workshops and retreats. This is another UW-Madison professor, Christy Tremonti. She has a collaboration with Dr. Lundgren over there on the right. And so they came with some Bates College collaborators. They stayed at Yerkes for, I think, 2 days, and they were up here for a couple days. So our interns got to come up here. I think they came and saw Washburn. Maybe the weather wasn't great. I can't remember.
That's right. It rained.
It rained. So they did. They got to sit into the collaboration meeting and just kind of see what it was like to work in a collaboration. And then Dr. Tremonti sent us this lovely message afterwards that her students, there were 16 students in this collaboration meeting, and for them, they felt really connected to the past and these powerful legacy of people that they've heard, and it helped them feel inspired to kind of lead the field forward more than just coming there to be a visitor. And so that, if you haven't been into this building, there's just something about it that really kind of elevates your experience and sets you into this creative mindset in kind of any direction you want to go. And that's something I'd really like to capture in just the uniqueness of what it can provide. Another random thing that happened to me, like, I tell you what, coming to this small town in Wisconsin, I've done a lot of things I never thought I'd have the opportunity to do. So the current Miss America, Grace Stanke, was crowned as Miss Wisconsin. Might not have known that. She's also, she just graduated from Madison with a nuclear engineering degree. And so we hosted her very first press event announcing herself as Miss America at Yerkes Observatory, kind of in support of her message that nuclear energy is something that we really need to get into, also women in science. So those were kind of her two messages in her year of service. She brought all of her friends. We got to speak to the crowd, and so I got to stand up and speak first, and then Miss America spoke, and number one, what do you wear when you share the stage? I'm a scientist. And my daughter happened to be off school that day, and so she sees me getting all dressed up in the morning, and she's like, "Mom, can I get dressed up too?" And I said, "Sure." And so off she goes, and she comes back with her cape, which has a big eye on the back for Ida, Super Ida, and her mask. And so I just captured this great photo where she and Miss America are chatting. She's telling her very important things, and then she says, "Do you want to see my super speed?" Miss America was like, "Yeah." And she just took off down the hall. Cape fluttering in the back. So, you know, the capes, we like capes. So this, I think, is another example of sort of arts and culture and science all coming together in this unique place. Oh, and she also, her talent was violin. And so she played this really hauntingly beautiful song in the dome. And if you've ever been in there, there's a real echo and resonance. And so to hear it kind of bouncing around inside of the dome was really quite something. And so I think one of the last things I'll mention is that we're now opening up our nighttime programs to be able to observe. This is the 24-inch where we're letting people up, and we also have programs that look through the Great Refractor, which you can see through that open shutter over there glowing in purple. We have some limitations for how many people we can fit inside the building, and it's historic equipment, and I don't have a technical engineer on my staff right now, so we're slowly bringing these programs back. In the summer, we were certainly limited by wildfire smoke, as you would have been familiar with. Can't open the telescopes and get them all gunky with all that ash. And sky brightness continues to be an issue. We're kind of right in the center of the triangle of Madison, Milwaukee, and Chicago. So it's darker than a lot of small observatories around kind of the Midwest and East Coast. But that doesn't mean that we're not at risk for the sky brightness just to keep on creeping up and preventing us from trying to do some of the research work and the student work that we want to do. So I cannot give a public presentation without encouraging everyone to think about their lighting around their house. I like when there are a lot of kids in the audience because I can encourage them to walk around their house and see what's illuminated around their house. If you have outdoor lighting, you can always put it on a timer to turn it off. Even in our local area, people in Lake Geneva love to illuminate their trees. And they are beautiful. But nobody's out there looking at it after 10:30 or 11 o'clock. Turn those lights off. or have it be motion sensitive or detected, something like that. Also, the lighting that you have, if it's open and it just goes up, that's not helping anything. You're not actually illuminating the things you want to illuminate. So having those little caps on it really help you illuminate the part of the ground or the house that you actually want the light to go to. So these are small things that you can do to help save energy. Global warming is a real thing, and it helps us astronomers who are desperately trying to capture photons from the distant universe. So I will leave you with a message of come visit Yerkes. There's so many things you can do. We have different kinds of tours. It's not open admission, so you do have to buy a ticket. You can buy that online. But we've got night sky tours now. We're hosting workshops. You can come see the world's tallest glass tree being built on the weekends this December and tour the grounds. We have 50 acres of Olmsted design grounds. We have 5 bee boxes, an apiary that are beautiful, wild pollinator garden. We have about 4 miles of mostly ADA accessible trails that go through the old growth woods. And it's just a beautiful place to come. So we survived the ice storm that we had earlier this year. So thank you very much for having me. Thank you, everybody online.